Hello, Pirates. Today's topic is the immune response. With the immune response today, we're looking at how a pathogen enters your environment and how your body's immune system fights off the pathogen. So what we're looking at, and this is going to go in your notebooks on page 127, and we're just going to kind of follow through the story of the immune response. So what exactly is happening in your cells? So overall, what we're looking at here is, we're going to read it kind of like a cartoon. We are looking at the immune response. So how does your immune system work to fight off an infection? So the first thing that happens with your immune response is your immune system first has to be in contact with a pathogen. So that pathogen could come from something as simple as a sneeze. So it could be coming from like a sneeze, physical contact, an animal bite, sharing a drink or food. And two of the main pathogens that we talk about this year and in our notes the other day were viruses and bacteria. So over here I'm just going to draw a virus with its little spike proteins, and then down here I'm going to draw a little bacteria. Okay, and the bacteria also is going to have its own surface molecules. So I'm going to give the bacteria some surface molecules just like I gave the virus some surface molecules. And with these molecules on the surface of the bacteria or the virus, we refer to these surface molecules as antigens. Okay, and an antigen is just a surface molecule on the surface of a cell or a virus. So these are the surface molecules. And the surface molecules are kind of like you guys wearing your school ID. Your school ID for Braden River High School, it lets people know that you are a Braden River High School student and that you belong here on our campus. If you came on campus and you were wearing a school ID to another high school or another school, it would be an indicator that you are not a student at our school and that you don't belong here, okay? So you would then look like an invader. So with this, we have the virus with its antigens, its surface molecules, and the bacteria with its skin or its surface molecules. What's going to happen first is if I come into contact with a virus or a bacteria, my first defense, and you want to think of your body as a fortress, is going to be external. So we are going to have some external barriers that are our first line of defense against pathogens. So you can think of these external barriers on the outside of your body. These are going to be things like your skin, your hair. So pathogens get trapped in your hair. The mucus that lines the openings to our bodies, like our nasal cavity and in our mouth, our earwax, saliva, tears in our eyes, the oil on our skin, and even things like sweat. These are all part of our first line of non-specific, and it's an external defense. So it's non-specific, it doesn't matter what pathogen it is, and it is external, it's on the outside. So these external barriers, they all contain something that help break down the pathogens. And if you guys think of something that we talked about this year that can break things down in living things or put things together, the thing that can break things down are enzymes. So our skin, hair, mucus, earwax, saliva, tears, oil, and sweat, they all contain enzymes that can help break down those pathogens. So if I rub my eye and I get a pathogen in my eye, that first line of defense are going to be enzymes in the tears and in the mucous membranes. All right. Now, most of the time when we come into contact with the pathogen, these things right here, they take care of it. But every once in a while, it's going to get into our bodies. So the next part of our defense, these are going to be non-specific, so it still doesn't matter what pathogen it is, but they are going to be internal instead of external. So what happens with our internal defense, which is inside our body, certain chemicals, when a pathogen has been discovered, are going to be released to slow down or stop the spread of the pathogen. That could be moving from cell to cell. And there's a couple of different non-specific internal defenses. One of them is going to be a fever. So a fever will slow down or stop the spread of an infection. And it will slow down or stop the spread of the infection by heating things up. So if you guys have ever had a fever before, a fever is an indicator that your body is fighting an infection. And what a fever does is it raises our body temperature. And the increase in body temperature is going to change our body from being the ideal temperature for our cells to function and making it less ideal. So at certain temperatures, it could speed chemical reactions up. But once we get outside of that ideal temperature range, think like those charts for enzymes, the body might start slowing down its manufacturing of substances, or it might slow down the manufacturing of a bacteria cell. So the infected cells can't produce more of the virus, or the bacteria cell can't live as effectively. The other thing that's in here is also a non-specific internal defense, and that is the inflammatory response. And the inflammatory response happens with redness and swelling. So if you guys have ever had maybe like a sliver, redness and swelling at the site is part of the inflammatory response. So what this does is this increases blood flow to the region. That's why you see redness, the swelling as well, for that increased blood flow. And what it's going to bring into the area is it's going to bring those cells of the immune system there. So it's going to bring white blood cells. And those white blood cells are going to help fight that infection. Okay, so non-specific internal defenses, a fever, or the inflammatory response. Again, at this point, this could slow down or stop the infection. But your body, in the meantime, while the fever inflammatory response is fighting the infection, as well as potential enzymes from your non-specific external defense, you're also going to have your body switching into a more specific mechanism of fighting off the infection. So the first thing that's going to happen is we have these cells which are called macrophages. And here we have a macrophage, and the macrophage is kind of like a big Pac-Man. And they're going to kick off this specific defense. So while the macrophage is non-specific, it's going to change into something specific at this point. And what the macrophage does is it recognizes pathogens. So here we have the macrophage. And the macrophage is patrolling and looking for things that don't belong there. So if here we have our virus with its specific antigens, its surface molecules, the macrophage is going to notice this intruder does not have the right ID. Its surface molecules are different than what's supposed to be here. And what the macrophage is going to do is it's going to chomp on and gobble up this pathogen. It's going to break it down in the lysosome, and then it's going to display the surface molecule that it found on the outside. So it will actually display what it found that doesn't belong there to set off the alarm, to send the alert that the body is under attack. So what's going to happen is your body is then going to be alerted. So it's going to patrol through the body, showing all the cells that we have found something that doesn't belong here. And it's going to send out the alert or the, alarm. So it's time to wake up. And the cells that are going to be woken up are what we call helper T cells. Okay, so here we have a helper T cell. And the helper T cell might be snoozing. So this is a helper T. And the helper T cell is going to wake up. It's been notified that there's an invasion in the body. And so here we have an alert helper T cell. And so it becomes activated. And it's going to send out the signal to both B cells and other T cells that it's time to fight an infection. Now the helper T cell is going to encourage T cells to divide and multiply. So it's going to cause them to increase their army. And so what we're going to have happen here is we're going to have killer T cells. So TK is a killer T cell. And the killer T cells are going to go through a lot of divisions. Those cell divisions are happening through mitosis, and it's going to produce a whole army or a huge population of killer T cells. The same thing happens to B cells. So down here we have B cells, and these B cells are going to do the same thing. They're going to go through mitosis to create a whole bunch of B cells. So again, we're going to have an army of B cells to fight off the invasion. In the case of the killer T cells at the top, the killer T cells will destroy host cells that are located on the inside of the body. So what they'll do, or the inside of the cells, so they destroy host cells. So they search the body for cells that have been infected, and a host cell will sometimes send out an alarm. So inside of the host cell is making and manufacturing these little virus particles. And maybe it's going to get ready to release them. It'll actually send out like a distress signal, like, help, we're under attack. And so with the host cell that is infected with the virus, with its distress signal, the killer T cells can identify it. All right, so this pathogen is inside the cells. The viruses get inside the host cell. So this right here is a host cell. And what the killer T cell is going to do is it's going to release these things called like perforins and other enzymes and chemicals. And what they're going to do is they're going to dissolve the membrane and cause it to break apart and implode or explode. And so all of this is going to get released, and it's going to destroy the killer, it's going to destroy the host cell. And it will have like on patrol, it'll show like I'm looking for cells that are carrying this specific antigen. So this becomes a very specific defense, fine-tuned specifically for this antigen. With the B cells are going to kill pathogens that are on the outside of the cells. Okay, so it's going to look for not only bacteria, but even viruses on the outside of the cell. And what the B cell is going to do is it's going to look for a specific pathogen. So if you guys remember, the bacteria had that specific antigen. All right, and that specific antigen was its specific surface molecule. And so what the B cells are going to do is they are going to build antibodies that match that surface molecule. So if the antibodies here match they're kind of triangle shaped. So the B cells are going to build antibodies to match the shape of the surface antigen on the bacteria. And we call these cells plasma B cells. So plasma B cells that were created through mitosis, they are going to produce antibodies. And with these antibodies, they're going to attach them to those viruses. All right. Now, some B cells will just have that coordinating surface molecule, and they'll attach and cause the bacteria all to clump together. And some will actually just shoot the antibody at the pathogen. And when they shoot the antibodies or release the antibodies, they will attach to the bacteria, and they'll do a couple of things. They'll flag it for destruction, or it'll cause them to clump and stick together. So here we have a release of the antibodies. So the antibodies are released. So the antibodies are released, and what's going to happen is that cell is going to get tagged for destruction. So they either get tagged for destruction, or they'll clump up. So now this cell is tagged for destruction. And they kind of, like we read in the article, they tag for destruction, but they also cap the surface molecules in the case of a virus where they can't bind with the cell. So bacteria would go on the outside, but if it was a virus, it would cover them. All right, so they're tagged for destruction. So then things like the macrophages will come around like vacuums and gobble them up. Ultimately, in the end, what we're going to have is we're going to have a cell-mediated memory cells that are produced. So this very specific defense is going to remember the pathogens that were fought so that it can fight them in the future. So what's going to happen with these T cells over here is that very specific memory cells. So memory cells, very specific memory cells, specific to that virus. So memory T cells are going to patrol the body. And they're always going to be patrolling, looking to see if that virus ever is encountered again. And what they're going to be able to do is they're going to be able to fight an infection, or they'll be able to fight a pathogen. So they can fight a pathogen before illness sets in. So they respond faster and more quickly than the first time that you were infected. And you guys can kind of think about a video game. If you've ever killed like a bad guy at the end of the level, I'm thinking Super Mario Brothers. The first time you kill the bad guy at the end of the level, you don't know how to kill them. The second time you do it much more quickly and with more power because you've done it before. And this is what builds up your immunity. So your immunity, your specific immune defense, is tailored against the pathogens that you've encountered in the past. The same thing happens with your B cells. So again, specific memory B cells and antibodies are going to be present, are going to remember, and they're going to be stored or patrol for the future. So for example, after you guys have had an infection, they say that the antibodies peak after you've been exposed to something between 10 to 20 days after your infection. So your body stays on the lookout, it stays on patrol. And if it ever encounters that pathogen again, because it's made the antibodies before, it can make them quickly, and it can divide those cells faster so that you have a quicker and faster immune response. So again, the end result here is a built immunity based on the infections that you have already had. So for example, with the cold, you only get a cold virus once. The next time you get a cold, it's a different variation of that cold virus. It has mutated so that your cells can't recognize it anymore. All right, so what you guys want to do is you guys have these notes that are kind of like a comic strip. And with these notes, you guys are going to keep these in your notebook on page 127. And what you guys want to do, you have a worksheet to just practice the names of the cells and what they do. And then in addition to that, you guys are going to make a comic strip, okay? And with your comic strip, you're just going to kind of go through, and you can do it this way, vertical or horizontal. And you guys want to use these things like have a title for the pathogen, how it enters the environment, your non-specific defense, internal and external, recognition, specific defense, and your memory, like how it all ends up in the end with the memory cells. So you want to break up the topics across these 1, 2, 3, 4, 5, 6 boxes to put together a comic strip story of how this happened. And this will go in your notebook between page 126 and 127. You guys are going to have some matching on 126, so you'll have like a flap. And if you guys want to look at an example, here's an example from an anatomy class, so it's a little bit more specific, but you can see how they created a comic strip showing a specific pathogen. They chose, in this case, Salmonella, and they showed where it comes from, how it enters the environment, the cells that are going to attack it. And this person, they're showing you the Salmonella didn't make it, and now the Salmonella will have to find someone else because of the memory. Here they've got Congo fever, so they're showing what's happening. An E. coli infection, dengue fever, strep, so a strep throat infection. And here's another one with Salmonella. So you can kind of see they showed what's happening with the cells and how the resolution is those memory cells. All right, so you guys want to break up those topics that are right here, those basic headlines, and put them into your comic strip to make a comic strip. You guys can pick whatever pathogen you want. It just needs to be bacteria or a virus. Consider how it gets into your cells and then go from there. All right, if you have any questions, reach out and let me know. I hope you guys have a great day.